Continuing on the types of relations, a relation R in a set A is called reflexive if A comma A belongs to R for every A belonging to A. Symmetric if A1 A2 belongs to R implies A2 A1 belonging to R for every A1 A2 belonging to A. Transitive if A1 A2 belongs to R, A2 A3 belongs to R implies A1 A3 belonging to R for every A1 A2 A3 belonging to R. So, we have seen three types of relation, namely reflexive, symmetric and transitive. There is something called as a equivalence relation. What does this mean? A relation R in a set A is said to be an equivalence relation if R is reflexive, symmetric and transitive. Let us understand this using an example. Equivalence relation. Let us understand using two examples. So, let's consider the first example. Consider the set of all lines L such that we have L1, L2, L3, etc. We define a relation R on L with L1 related to L2 under the condition that L1 is parallel to L2 with L1, L2 belonging to capital L. So, we have L1 parallel to L2. This relation is reflexive because L1 is parallel to L1 itself. It is symmetric because since L1 is parallel to L2, it implies that L2 is parallel to L1. Now, to understand transitivity, we consider yet another line L3 in between L1 and L2. So, if L1 is parallel to L3 and L3 is parallel to L2 implies L1 is parallel to L2. Therefore, transitivity is also satisfied and hence R is an equivalence relation. Now, let us consider the second example. Let A be the set of all triangles. In this set, we define a relation R such that triangle 1, namely delta 1 is congruent to delta 2 with delta 1 and delta 2 belonging to A. So, can we discuss the situation, it is reflexive because delta 1 is congruent to delta 1 itself, which implies delta 1 comma delta 1 belongs to R. Symmetric because delta 1 congruent to delta 2 implies delta 2 is congruent to delta 1, with delta 1, delta 2 belonging to R. Transitive because if we consider yet another element, namely delta 3 belonging to R, delta 1 congruent to delta 2 and delta 2 congruent to delta 3 implies delta 1 is congruent to delta 3. Therefore, all three conditions are satisfied and hence R is an equivalence relation.